Hello students, welcome you to this session. We are studying sets, relations, functions. In the last video I taught sets and we did sums from the first exercise and example sums we finished. Now in this class we are going to do the second one. So that is the relations we are going to study in detail. But before that, constants and variables. You know what are constants, what are variables? Constants normally we denote as numerals, okay, 2, 3, 7 like that. And even A, B, C we denote it as what? Constants. M, y equal to mx plus c, right? Y equal to mx plus c. Here m and c are what? Constants, slope and y-intercept. All these are constants. There are two types of constants. This 2, 3, 7 are numerical constants, right? It has some specific value. So they are numerical constants. And this A, B, C, M, all these constants we call it as arbitrary constants. In different sums it takes different values, right? Different situation it takes different values. For example, m is the slope. For one line the slope may be 2 by 3, in another line slope may be 1 by 2 or 1 by 7, whatever it is, right? So it's a constant, but it changes, right? So every sum it takes different values. So such constants we call it as what? Arbitrary constants. Variables, you know, normally we denote it as what? X, Y, Z. So it varies, right? So now there are two types of variables. Constant, two types we said, right? Arbitrary constant and numerical constants or fixed constants. And here variables, independent variable and dependent variable. For example, if I say y equal to 2x plus 3, y equal to 2x plus 3. When I put x equal to 1, what is y value? 2 into 1, 2 plus 3, 5. If I put x equal to 0, what is y value? It is 3. If I put x equal to 2, 2 2s are 4, 4 plus 3, 7. As x varies, y also varies. So y depends on x. When I change x value, it affects y, right? So here x you can give any value. Depends on that, y changes. Okay, so y depends on x. So here x is called independent variable. And y is called dependent variable. So when y equal to a function of x, y is a function of x, then this x is called independent variable and y is called dependent variable. Suppose x is a function of y, then y is independent, x is dependent because x depends on y. Now, intervals. There are different types of intervals. Finite interval, infinite interval. Finite interval, for example, say 7 to 10, it is finite interval. Or say 2 to 10, some closed interval. I'll tell you what is closed interval, what is open interval. So these are finite interval. Infinite interval means one end must be infinity or minus infinity or both. Suppose it may be minus infinity to 7 or 3 to infinity, or even minus infinity to infinity. All these are infinite intervals. It goes up to infinity, or it goes up to minus infinity, or minus infinity to plus infinity. So these are different types of intervals. Then in finite interval, here you can see closed interval and open interval. The first one is open interval, 7, 10. What is the meaning of this, you know? You take every point between 7 and 10, but don't take the end points. End points are excluded. So if you write as inequality, 7 less than x less than 10. 7 less than x less than 10. If you draw in number line, minus infinity to plus infinity, we want 7 to 10. 7 is here, 10 is here. So the portion in between. So this is open interval. Suppose closed interval 7, 10 means closed interval 7, 10. The meaning, say minus infinity to plus infinity. The endpoints are included, right? So if you want to write it as inequality 7 less than or equal to x less than or equal to 10. Okay, so that is closed intervals. Okay, endpoints are also included there. Okay, so here 7 to 10. So 7 is here, 10 is here. In between, in open interval we take only this, right? Closed interval the endpoints are included. So the circle you darken. You shade that circle also. So that means that point also included. 7 and 10 are also included. And we have intervals like this also, 7, 10. Can you see the difference? left to open, right? 7 is not included, but 10 is included, right? So 7 less than x, but less than or equal to 10. Okay, so when you draw in number line, minus infinity to plus infinity, say 7 is here, 10 is here. In between you can shade. 7 is not included, so don't shade that one, don't darken that one. 10 is included, so you can darken that. So are you able to understood? So these are intervals, so you can denote it as inequality, also you can denote in the graph, okay, in the number line. Neighborhood, neighbor nearby, right? Suppose I am taking a number, say A. Its neighbor means some portion left side, some portion right side. You take a very small number. We take the number as, say, epsilon. Epsilon is a number. Okay, epsilon is a very small number. So A is 1 point. You in the right side add epsilon, left side subtract epsilon. Okay, so here 1 point, here 1 point, here 1 point. Okay, so this distance is epsilon. This distance also epsilon. Since it is the right side, this is A plus epsilon. It is the left side, so A minus epsilon. A is in the middle. Okay, so this interval, A minus epsilon to A plus epsilon, is called a neighborhood of the point A. It's a neighborhood, it's an interval, okay? So which contains that point, that is called neighborhood of that point. Then another one is there, deleted neighborhood. Deleted, you should delete something, right? If you delete that A, then that neighborhood we call it as what? Deleted neighborhood. That particular point is not there, all other things are there. A minus epsilon to A plus epsilon, except A. Okay, so removing that A, delete that A. So that we call it as deleted neighborhood, okay. Now let us go for relations. Listen, what is relation? You know ordered pair, right? You know ordered pair. Then you know Cartesian product, A cross B. Cartesian product means what? Set of ordered pairs, right? Set of ordered pairs, that is Cartesian product. From that Cartesian product, you write a subset. You take few ordered pairs and you form a set, and that is called relation. So relation is a subset of Cartesian product. Okay, so relation, it is a subset of Cartesian product. Then you know what is domain. The first set fully we call it as domain, second set call it as codomain, and the related elements that we call it as what? Range. Okay, so all these things you know. Then what is image, what is pre-image? Suppose 5 is related to 7. Under the relation f of 5 is equal to 7, right? Image of, or you write as an ordered pair, 5, 7. The image of 5 is 7, and the pre-image of 7 is what? 5. So now we are going to study. There are two types of relations. One is the smallest one, that is called empty relation. So nothing is there. Because any subset you can write, no? Empty set is a subset. And the whole set is also a subset. Whole set means A cross A. And that one we call it as universal relation. The entire set A cross A. So that is called universal relation. Like universal set which contains everything, right? So the biggest one, that is called universal relation. And empty relation, so there is no element. So that relation we call it as what? Empty relation. Extreme relations, the two extremes. In one there is no element, another one it contains everything. That is A cross A. Okay, so these are called extreme relations. Okay, now we are entering some of the very important one. This full exercise 1.2 is mainly about these types of relations only. So there are three types of relations we are going to study. So one is reflexive, second one symmetric, then transitive. Reflexive, symmetric, and transitive. Relation, okay, relation means say is a factor of, is a multiple of, is a square of, is 5 less than. All these are relations. In a family situation, we can say brother of, sister of, mother of, or friend of, okay. In human being, we have all these relations. So in numbers, we have some other relations like this. Is a multiple of, is a factor of, okay. Is less than, is perpendicular to, is congruent to, is equal to. All these are some relations, okay. So there are three types of relations I said. The first one is called reflexive relation. Reflexive relation. So here they will give a non-empty set. Say S is a non-empty set. Let S be a non-empty set. The set S has some elements. Okay. So then reflexive relation means every element is related to itself. Every element is related to itself. A non-empty set is given, right? S is a set, it contains some elements. Then in the relation, every element must be related to itself. Suppose S is a set, say 1, 2, 3. Then in the relation, you must have 1 is related to 1, 1 is related to 1, 2 is related to 2, 3 is related to 3. If every element is related to itself, then only we can say it is reflexive. Even if one term is not there, suppose this 3, 3 is not there. 1 is related to 1, 2 is related to 2. But in S, 3 is there. So that element is not related to itself. Then you say it is not reflexive. Every element must be related to itself. Then only we can say what? Reflexive relation is satisfied. So you can write like this. In general, we can't write one by one like this. So A, A belongs to R. For every A belongs to S. So this is a symbol for every, therefore, since, that is, these are some of the symbols, right? When you go for higher classes, these are some symbols. This is for all or for every. You take any element from S, any element A from S, A is related to A. Every element is related to itself. So every element related to itself, you can write like this. Or you can say A related to A. A related to A. Every element related to itself. So that is reflexive relation. If you want, I'll give some examples. So try to understand properly, because then only you can do the sums. Here no formula, nothing. Just you have to think and say. See, every element related to itself. Can you give some example? Equal you can say. Because every element is equal to that number. 5 is equal to 5. 7 is equal to 7. A equal to A. K equal to K. Every element is equal to itself, right? So equal to is reflexive relation. Equal to is a reflexive relation. Equal to. It is an equivalence relation. Then parallel. In the case of lines you take, suppose a line L is given. The line L is parallel to L. The line M is parallel to M. A line is parallel to itself. So you can take parallel, you can say. Perpendicular you cannot say, right? A line is not perpendicular to that. You cannot say that one. Then congruent you can say in case of triangle, right? Congruent. Then subset. A set is a subset of itself. It is correct only. Okay, so these are all for examples for reflexive relation. And you must know examples for non-reflexive also. Someday they will ask the question like this. So give a relation which is reflexive or which is not reflexive. Okay. So now let us go for the second relation, that is called symmetric. So reflexive means every element related to itself. Every element must be related to itself. What are the elements you have in the set? It must be related to that. Then symmetric, it is different one. Now please listen, not for all the elements. Symmetric. If A related to B, if A related to B, then B must be related to A. B must be related to A. Or how can you write this? If A is related to B, implies B must be. Or you can say then. It is if then, conditional. If A is related to B, then B must be related to A. If A is related to B, then B must be related. If A is not related to B, no need to check. If A is related to B, then B must be related to A. If A is not related to B, you no need to check B related to A and all. Okay, so there is a condition. So here I'll give some examples. Here also you can say equal to. Listen. Suppose A is equal to B, then definitely B is also equal to what? A. Just reverse it. A is equal to B, B is equal to A. Equal to. Perpendicular you can say, right? Perpendicular. Line L is perpendicular to line M. then M is also perpendicular to L, right? Then what you can say, parallel you can say, this line L is parallel to M, then you can say M is parallel to L. What about less than? 2 is less than 5. Can you say 5 is less than 2? No. So it is not symmetric. This is example for non-symmetric. Greater than, it is not symmetric. What about friend of? You think about your friend. Yes, he is, that person is my friend. So I am his friend. Just opposite, right? Both conditions satisfied. Only we call it as friend, right? Otherwise, it's not a friend. A is a friend of B. Then definitely B must be a friend of A. Then only A is my friend, right? So that is our which relation? Symmetric relation. So reflexive means every element related to itself. But symmetric means if A is related to B, then B must be related to A. If A is the friend of B, then you check whether B is a friend of A or not. If not, don't worry about it. Okay? So that's only a condition. And the third one is a very important one, transitive relation. Transitive relation. What is transitive relation? It transfers. Suppose A is related to B, A is related to B, B is related to C, then if you are able to say A is related to C, then you say it is transitive. So it transferred from B to C, right? Transferred from A to B, then B to C, then it is what? Transferred from A to C. So this relation we call it as what? Transitive relation. Okay, now please listen here. I'll give some examples. Here also you can say equal to. So how to write the result? A, here also condition only. Okay, if A related to B, A comma B belongs to R, that is A related to B and B related to C. Then condition, if this part is true, then only you have to check this. If that does not exist, then no need to check anything. Okay, so then A must be related to C. If A is related to B and B is related to C, then A must be related to C. So this relation we call it as what? Transitive. That is, if A is related to B and B is related to C, then A must be related to C. Okay, so this relation we call it as what? Transitive relation. So see some examples. For all this you can say equal. Equal to is transitive because A is equal to B and B equal to C. A is equal to B, B equal to C. So definitely you can say what? A is equal to C. Parallel you can say. Then congruent you can say. Like that, some standard examples you remember so that in the exam time you don't need to waste time, you think for that and all. Okay. What about friend of? Is it transitive? Friend of A, B, C. See, A is a friend of B. B is a friend of C. Is it necessary A is a friend of C? Not always, right? Suppose A and B are school friends. B and C are neighbors. Their homes is some place but nearby. They are studying different schools. Then this person A may not know even C, right? He may not know who is that C, right? Need not be. Okay, so it is not transit. Okay, like that. So try to understand the meaning of that. Try to understand the facts and the concepts behind that. Then you can answer any question. No formula in this exercise. Okay, fully reflexive, symmetric, transitive. So 3 types of relations. Then if all the 3 relations are satisfied, then that relation has a special name. It is called equivalence relation. It is called equivalence relation. What is equivalence relation? A relation R is said to be equivalence if it is reflexive, symmetric, and transitive. What is reflexive? Every element related to itself. What is symmetric? If A is related to B, then B must be related to A. What is transitive? If A is related to B and B is related to C, then A must be related to C. Okay, so that is transitive. If all the 3 relations are satisfied, then that relation is called equivalence relation. Can you give an example for equivalence relation? Yes, our famous examples in everything we said, right? Equal to equivalence relation, parallel to is an equivalence relation, then congruency is an equivalence relation. Okay, try to remember few examples, okay? Now, few results you remember for objective questions. The number of relations, total number of relations from a set containing m elements to a set containing n elements. The first set containing m elements, second set containing n elements, then how many relations can be formed? 2 raised to m into n. M is the cardinal number of first set, n is the cardinal number of the second set, then total number of relations equal to 2 raised to m into n. Suppose the first set contains n elements, second also n elements, then n into n, 2 raised to, first I said 2 raised to m into n. If both are same, 2 raised to n into n, it is n square, right? In particular, the number of relations on a set containing n elements, then it is 2 raised to n square. How we are getting? 2 raised to m into n. That both are now n. This is also n. So n into n, it is n square, okay? Then this two results you remember. Number of reflexive relations, if they ask, this is a formula, 2 raised to n square minus n. Number of symmetric relations, 2 raised to n square plus n by 2. So for objective question they can ask, sometimes they give some number. Suppose a set contains 5 elements, then how many symmetric relations can be formed? So take the formula, for n you substitute that value. Okay, so these 3 results you have to remember. That's all the theory part for the second exercise. Second exercise is one of the very simple exercise. Example sums also quite easy only. So first exercise I said the examples are entirely different, so I taught separately. So we uploaded separate video for what? Example sums, then separate video for all the example exercise sums. So, but this is a very simple one. So I'm going to teach only the exercise sums. So example sums you can just go through, definitely you can understand easily. Okay. Now just listen this. So when I'm teaching every sum, I try to explain as much as possible. Okay. Then you can answer any question. See the first question. Discuss the following relations for reflexity, symmetricity, and transitivity. So only thing you must be thorough with what is reflexive, what is symmetric, what is transitive. Listen. What is the first they said? The relation are defined on a set of positive integers. Positive integers. So 1, 2, 3 onwards. Okay, that is set of natural numbers. And what is the relation here? M is related to n. M is related to n. If you want to say m divides n. M divides n. If m divides n, that is m divides n. That means the remainder must be what? 0. So m is a smaller number, n is a bigger number, right? N you can divide it by what? M. The remainder is 0. Then you can say m is related to n. You know, 8 you can divide by what? 2. 4 2s are 8, the remainder will be 0. So you can say 2 divides 8. 2 divides 8. So in this case 2 is related to 8. Because 2 divides 8, right? Okay, now what they asked here? So we have to check all the relations, right? Are you able to understand what is when can you say it is related? So every sum they change. Here they said 2 elements are related. M is related to n. First number is m. You cannot even change the order. First number is m. Second number is n. M is related to n means m divides n. Okay, so the first two you have to check reflexive. Reflexive. Listen, what is reflexive, you know? So, every element related to itself. Can you say every element related to itself? Yes, every element divides itself. 5 divides 5. 5 by 5 it is 1, remainder is 0, right? So, every element divides itself, right? So, A divides A. So A is related to A. A is related to A. Therefore, what you can say? It is reflexive. So even for one element it is not true, you should say it is not reflexive. Okay. Now, same question we check the second one. Symmetric, right? So now we have to check for symmetric. Earlier I said one example, no, I am taking that. 2 divides 8. 2 divides 8, right? 2 divides 8. 8, that is 8 can be divided by 2. But 8 does not divide 2. So 2, can you divide by 8? No, it is point and all, right? So 2 divides 8. 2 is related to 8, but 8 is not related to 2. You can write like this, or you can write the difference symbols you try to understand. So 2 is related to 8. 2 comma 8 belongs to R. 2 divides 8. But 8 comma 2 not related. Okay, so therefore what can you say? A related to B related to A, then only you say it's symmetric. So here not satisfied, therefore it is not symmetric. Okay, now we check the third one. What's the third one? You have to check for what? Transitive. Transitive means 3 we need, right? So please listen here. Now transitive, what we do, we take one example. Then you can understand better. 2 divides 8 and 8 divides 40. Because 40 can be divided by 8, no? Yes. Can you say 2 divides 40? Yes. 2 divides 40. 40 you can divide by 2. The remainder will be 0. It is true, right? So now in symbol we write. So for every A related to B, A related to B, A comma B belongs to R and B comma C belongs to R implies A comma C. A is related to C. Therefore it is transitive. You cannot do, so just I given one example for you to understand, okay? So you cannot do so many, right? We write in general. So we check it. If it is satisfied, you write in general. Suppose if it is not true, show one example and you say, so it is not transitive, okay? So when it is true, so it is true for every element, right? So everything it should be true. You cannot write everything. So we generalize and write, okay? And they didn't ask you to check whether it is equivalence or not, right? It is not equivalence, you know. If all the 3 are true, then only we say equivalence. Here reflexive and transitive, but it is not symmetric, so it is not an equivalence relation. See the next example, next question you see. Let P denote the set of all straight lines in a plane. Straight lines in a plane and the relation L related to M. L is related to M if L is perpendicular to M. If L and M are perpendicular, so here the relation is what? Perpendicular, okay? So first reflexive. Satisfied or not? You take one line. Same line you say again, in between you say the word this relation. Which relation? Perpendicular to. A line L. L is perpendicular to L. L is perpendicular to L. No. L is parallel to L, you can say. Just it coincide, okay? You say they are parallel. But it is not perpendicular. So it is not reflexive. A comma A not belong to R. Okay, so or you can say L is not perpendicular to L. L is not perpendicular to L. So you can say it is not reflexive. Okay, so L comma L does not belong to R. Therefore it is not reflexive. What about symmetric? Second, you have to check symmetric, right? You consider 2 lines. For easily, x-axis and y-axis take. X-axis is perpendicular to y-axis. Y-axis is perpendicular to x-axis. So it is symmetric, right? So L is related to M. L is related to M. So if L is related to M, then M is related to L. So it's satisfied here, right? So it is a general one. It's satisfied, so just we write it. So therefore it is symmetric. So now the next relation, what's the next one you have to check? Transitive, right? So next one we have to check transitive. So transitive, first you think about that, then you write, okay? Suppose say this is a line, L. L is perpendicular to M. L is perpendicular to M. L perpendicular to M. So there is a relation, right? And now I'm taking another one. Say this is P. First L is perpendicular to M. Now M is perpendicular to P. M is perpendicular to P. There some relation exists. Can you say L is perpendicular to P? See the diagram? L and P, they are not perpendicular, they are parallel, right? So, but L comma P, that relation does not exist. Therefore, it is not transitive. Hope you understood that, okay? Now see another one I am taking. On the set of natural numbers, the relation R defined by X is related to Y. X is related to Y. If you want to say on a set of natural number, natural number starting from 1, 2, 3, etc. only. So when you say X is related to Y, X plus 2 times Y, you have to get 1. Can you give one example? You say for X and Y, you give two natural numbers. A natural number plus 2 times another natural number, will you get 1? Smallest natural number itself 1, right? So 1 plus 2 into some natural number, you won't get 1. So you are not going to get any element here. So it is only an empty set. So empty set means the relation is what? Empty relation only. Okay, it is an empty relation. In empty relation, you say it is not reflexive. Not reflexive means at least some element should be there. Every element must be related to itself. Okay, so for empty relation is not reflexive. Okay, so reflexive property not satisfied, not reflexive. Symmetry transitive, you can say it's satisfied. Why? What is the condition is there? Symmetric means if A is related to B, then only you are going to check. If not, you don't need to check anything, you say it is symmetric. Transitive also like that only. If condition is there, if A is related to B and B is related to C, then only you have to check whether A is related to C or not. If the condition itself not satisfied, no need to check it, but you cannot say not satisfied. Okay, so it's satisfied only. If A is related to B, then B must be related to A. If A itself not related to B, so no need to you check anything. So you cannot say it is not symmetric. Okay. So it is, when can you say it is not symmetric? A is related to B, but B is not related to A. Then only you should say it is not symmetric. Okay, here you cannot, A itself not related to B, then you no need to check at anything, but you can allow. You say, yes, it is symmetric. Okay, so here no elements. So you cannot say it is not symmetric. You cannot say it is not transitive. So we say it is symmetric and it is transitive. It is symmetric. Only empty relation is not reflexive. Okay, so that alone you keep it in mind. Now we go for the next question. Listen, it's a very good question. Listen carefully. X equal to ABCD. X equal to ABCD. R is a relation. R, they given a relation here. A comma A, B comma B, A comma C. Now, write down the minimum number of ordered pair to be included to R to make it reflexive, symmetric, transitive. Okay. So one relation given. Now we have to check, is it reflexive? If it is reflexive already, you say no need to include any element. Suppose if it is not reflexive, you see which element to be added here, so that to make it as what? Reflexive. What is reflexive? Every element related to itself. What are the elements in the set? A, B, C, D. A, B, C, D. So every element must be related to itself. That is for reflexive, no condition. What are the elements there? Every element must be related. So A must be related to A. Yes, it is there. A is related to A is there. B must be related to B. Yes, it is there. C must be related to C. C comma C, it is not there. D comma D, it is not there. So it is not reflexive now. To make it reflexive, that two elements should be added. That is what they asked. Write down the minimum number of ordered pairs to be included to R to make it reflexive. To make it reflexive, two elements to be added. Which elements? C comma C and D comma D to be added. Okay, we go for the second part. Second part is symmetric. Is it symmetric? Symmetric means don't check everything. In the given relation, you say, suppose A is related to B, you reverse and check. Suppose 2 related to 3, you check whether 3 related to 2 is there or not. If not, it is not symmetric. You have to include that. Okay. So here A comma A, even if you reverse A comma A, it is there. B comma B, if you reverse, it is B comma B, it is there. A comma C is there. A comma C is there. So if you reverse, C comma A should be there. Because A is related to C, so C must be related to A. It is not there. So it is not symmetric. To make it symmetric, that one extra ordered pair to be included. So which one to be included? C comma A. C comma A to be included to make it what? Symmetric. Okay, so you can write the sentence fully. So you don't say, sir, C comma D is not there. No need. What is there? You check that. If condition is there, if A is related to B, then only you have to check whether B is related to A or not. So here C comma D is not there. Then why should we check D comma C, right? If it is there, if C comma D is there, then D comma C also must be there. Okay. Now we check for transitive. So for transitive, what are the things to be included? Listen, transitive means A related to B and that B related to something. So see here, A related to C, A related to A and that A related to C. A related to A and A related to C, then these two must be same, right? Then A must be related to C. Yes, it is there. Then B related to B, then that B related to nothing is there. A related to C, then C related to nothing is there. So no need to check anything else. So you say it is transitive. So nothing to be included. Nothing to be included. So it is not reflexive. To make it reflexive, two elements you have to include. It is not symmetric. To make it symmetric, one element should be included. It is already transitive, so to make transitive, no need to include anything. And the last one, for equivalence, what are the elements to be included? So for equivalence, equivalence means it must be reflexive, it must be symmetric, it must be transitive. So what are the elements we added here? That everything you write here. First we added C comma C, we included C comma C, D comma D. Then for symmetric we included what? C comma A. All these three to be included to make this as what? Transitive. Okay, so hope you understood. Now we see the next one. A is ABC and R equal to A comma A, B comma B, A comma C. So A is a set ABC. R is a relation. A comma A is there. B comma B is there, but C comma C is not there. A comma C only there, right? So now we can say it is not reflexive. Why it is not reflexive? What is missing? C comma C is missing. So what should be included to make it reflexive? C comma C. No D here, okay? Symmetric. If A is related to B, B must be related to A. So here A comma A, even if you reverse A comma A only. B comma B, if you reverse B comma B only. A comma C, if you reverse C comma A, it is not there. So to make it symmetric, you have to include C comma A. Transitive, A related to A related to C. So A related to C, B related to B, then B is not related to any other element. A related to C, then C is not related, nothing is there. So it is transitive, nothing to be included. So for equivalence, you have to add what? C comma C and what? C comma A. These are the two things. So you complete up to this one. So the remaining sums I will teach in the next video.